Once you have a suitable sentiment lexicon, you can perform supervised learning of word sentiment. I'll describe techniques for performing supervised learning of word sentiment in this video. I'll start by discussing normalized word likelihood, followed by log odds ratio. Having access to a labeled corpus of positive and negative texts allows us to learn linguistic patterns associated with sentiment, as well as mappings from unlabeled test documents to the correct sentiment label. This can be done using any of the statistical and neural models we've discussed already, by extracting engineered features or word embeddings or a combination of the two from a set of instances and using those features to train a classification model. If we want to learn to predict the sentiment of a given word, we might also do quite well just by using word likelihood or other simple statistical measures. One way that word sentiment scores have been learned in the past using simple probabilities is by computing normalized word likelihood. Normalized word likelihood is simply the frequency with which a given word occurs in a given class, divided by the frequency with which the word occurs in any available class. If we're working with a vector of sentiment categories, for example, if we're trying to predict the sentiment of an IMDb movie review ranging from 1 star to 10 stars, we can compute the normalized word likelihood for each category and then visualize the scores for a given word in what is called a POTS diagram. It's a graph where the x-axis corresponds to the sentiment class and the y-axis corresponds to the word's normalized likelihood for that class. POTS diagrams provide useful visualizations of word sentiment, and some examples provided in the textbook are reproduced here. For example, strongly positive or negative words tend to have growing upward or downward curves, and weakly positive and negative words often have curves that are raised near the middle and lower on the extremes. POTS diagrams can also be used to characterize different word subcategories. Emphatic verbs like totally or absolutely tend to have J or U-shaped POTS diagrams, whereas attenuating verbs like somewhat or fairly tend to have humped diagrams more similar to those of weakly positive or negative words. Another way to probabilistically learn a word's sentiment is to learn how closely affiliated with a given class it is. For example, going back to the movie review example, there may be some words that are very closely associated with 1-star reviews and some words that are very closely associated with 10-star reviews, but there may also be quite a few words that show up in both 1-star and 10-star reviews. Computing the raw difference in frequencies in those cases may not be the most informative approach to learn the word's sentiment, because for words that are very frequent across all classes, even a relatively small percentage difference may look like a big raw difference. And for words that are very infrequent across all classes, even a relatively large percentage difference may look like a small raw difference. A more sophisticated way to identify words that are overrepresented in specific categories and thus highly likely to be associated with them is to compute the log odds ratio with an informative Dirichlet prior. In this measure, we essentially learn a prior estimate of expected word frequency from a large external corpus and use that to moderate a more traditional log odds ratio. The standard log odds ratio is computed as shown here, where we represent the count of word W in the corpus I as F with a subscript of W and a superscript of I, and the total number of words in corpus I as in superscript I. P superscript I of W is thus the probability of a word W existing in the corpus, given those values. We simplify the log odds ratio equation to what you see on the bottom here. In the equation for log odds ratio then, we're computing the ratio of encountering a word in corpus I versus corpus J, where perhaps I and J correspond to corpora of positive and negative words, respectively. When we modify this equation with an informative Dirichlet prior, we add a term alpha based on a background corpus. Alpha sub 0 is the size of the background corpus, and alpha sub W is the number of times the word W occurs in that background corpus. Finally, we can estimate the variance of the log-odds ratio, as shown here, as 1 divided by the sum of the frequency of word W in corpus I and the count of the word W in the background corpus, plus 1 divided by the sum of the frequency of word W in corpus J and the count of the word W in the background corpus. For the final statistic then, we take the z-score of the log-odds ratio we previously computed, ending up with what you see here. This controls for the amount of variance in a given word's frequency. Overall, computing the log-odds ratio in this manner allows us to identify words that are closely associated with specific classes. In the context of our discussion in this module, these classes correspond to sentiments, but more generally, one can compute this for any classes. A representative use case has been identifying words closely affiliated with partisan speech in political contexts.